But I will say, I personally think incompatibilism is false. If determinism turns out, I don't think it would threaten free will in the slightest. If anything, I think it might guarantee free will. If scientists gave us a proof tomorrow of determinism, a lot of philosophers would say, yes, we've got free will. And other people would say, what are you talking about? That would mean we don't have free will. We'll get into that some next week. But let's at least try to appreciate, before we go back into this, into the details, why would so many people at least think that there's a clash between free will and determinism? Let's go back to our, how can we work this out? What do we mean by determinism? What do we mean by free will again? What's our working definition of free will? Ziana, what's our working definition? Agency. And what is our working understanding of agency? Directing our body, directing our thoughts through our choices. We could also say through our decisions. Choices, decisions for us are the same. Okay, what is determinism? Gabe, what is determinism? Do you have your hand out?
Basically that everything is already planned.
Not necessarily planned by like an intelligent being.
But like it's already
It's already fated to happen.
Yeah, let's not use the word fated though. Right.
It's inevitable.
It's inevitable. Inevitable. Let's say that. We take the laws of nature. That's where the determinism is supposed to come from. That's the source of it. The laws of nature, the laws of physics. We slap those on the beginning of the universe, and we can only get one possible future, one possible outcome. Right? Okay. Why think these can't go together? Why can't we have agency if we're determined? Eliane, you said last time, we're still making choices.
Because, like, it's not good choices.
The choice is already inevitable, right? So that, then now maybe you do want to start talking about being fated or something, right? The choice is inevitable, it's not really ours, da 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 da. What do we want to do at this point? If we want to figure out whether we got free will, well, we've got to figure out whether or not determinism is true. How could we possibly do that? Who's going to tell us whether determinism is true, if anybody? Okay, good. So we're going to start talking to scientists, right? And again, why do we care about quantum mechanics? Brief review. What is quantum mechanics a theory of? What is it a theory about? It's about atoms and their parts, atoms and subatomic particles. Subatomic means below the level of the atom, the things that make up atoms. Why should we care about that?
Because if you could calculate everything's going to be, then it's true.
Why are atoms relevant to choices? We think our choices come from our brain, and our brain's made out of atoms. Now again, you might say, wait a second, I believe in a soul. Would a soul help us out? Not necessarily at all. We might talk about that actually if we have time. It's not clear that a soul would help us out at all. You would definitely need to believe in God for the soul to do any work for you here, right? But we're going to put that aside and just see what we can do with this. So what did we learn about quantum mechanics? What does it tell us? Is determinism true or false? Everyone's got the handouts? Let's read this paragraph. Anyone want to read this paragraph? We went over Evan, yes. So let's read this paragraph. Now again, this is Ted Sider, philosopher, right? Not a scientist. But again, his wife is actually one of the leading philosophers of physics in the world. I imagine he has studied this to some extent. This guy certainly has got a very strong grounding in mathematical logic. But what is he going to tell us? Yeah, Evan, do you want to read this?
Before moving on, we should investigate a side issue, whether quantum mechanics bears on the problem of freedom. Quantum mechanics is a theory of tiny particles. This theory was developed in the early part of the 20th century and continues to be accepted by physicists today. Quantum mechanics indeterministic. It does not predict with certainty what will occur, it only gives probabilities of outcomes. No matter how much information you have about a particle, you cannot predict with certainty where it will be later. All you can say is how likely it is that the particle will be found in various locations. And this is not a mere limitation on human knowledge. The particle's future position is simply not determined by the past, regardless of how much we know about it, only the probabilities are determined.
Okay, thanks. What is Sider telling us? Is quantum mechanics deterministic or indeterministic?
Indeterministic.
He's saying it's indeterministic. He is hedging on that a little bit. Notice how he says quantum mechanics and then he puts in parentheses, or at least a certain version of it. Again, what is that implying? When he says quantum mechanics, or at least a certain version of it, is radically indeterministic. By the way, to say it's radically indeterministic means it's not even close to being deterministic. Like, it's not deterministic, and not just by a little bit, but by a lot. When he says, or at least a certain version of it, what is that telling us? Why doesn't he just say quantum mechanics is radically indeterministic? Why does he say, or at least a certain version of it?
Because we don't know the absolute truth.
So say a little more. If one version of it is indeterministic, what does that imply? What does that imply? That another version is?
Or deterministic?
Yeah. Yeah. Do you think he really should be writing as if it just is indeterministic, if there's at least a version of it on which it isn't?
Yeah.
I'm not sure he should be doing this. I'm not sure this is a very good way to write. I think he might be kind of skewing things for the reader. He's kind of shouting, it's totally indeterministic, except not everybody agrees with that. Not sure that's really a good way for him to write. What questions do we want to ask now, y'all? Where should we go from here? Can we just say determinism is false? Are we done? We know everything is safe for free will? What would you want to do next to try to sort this out? What do you think we should try to do? If we want to figure out whether determinism is true or not. We want to know whether we have free will, right? What could we do next? Evan, do you have an idea?
Try the other versions of quantum mechanics, because like it says one version, a certain version is deterministic, so maybe like the other ones are.
Yeah, so this is an interesting thing too. Yeah, good. So we can just start asking too, just what are the versions? How many versions do we have? Who came up with these? How many are indeterministic? How many are deterministic? How many physicists believe in each? We might also just ask, what do scientists have to say about this? Right? So let's do this. Let's read. I didn't bring the books with me again today. I brought them the other day. Let's read this, or at least a paragraph of this. This book is called The Strange World of Quantum Mechanics. This is not by a philosopher. This is by a physicist. This is by a scientist. I'll show you the book. I forgot to bring the books with me again today. I'll show you a picture of it. Let's see what this guy has to say. So here's the book, Strange World of Quantum Mechanics. All right, it's published by Cambridge University Press. This guy is a professor at Oberlin College, which is a very fancy college, right? If you read the reviews of this book, and this guy's a very well-decorated scientist, and if you read the reviews of this book by other scientists, they're glowing reviews. People say it's one of the best books ever written on quantum mechanics by a leading scientist who's a specialist in quantum mechanics. Let's read this first full paragraph on page 2. Anyone want to do that? The paragraph that starts one strange aspect? Okay, go for it, Gabe.
One strange aspect of quantum mechanics concerns predictability. Classification mechanics is deterministic. That is that if you know exactly the situation as it is now, then you can predict exactly what it will be at any moment in the future. Chance plays no role in classical mechanics. Of course, it might happen that prediction is very difficult to perform, or it might happen that it's very difficult to find exactly the current situation. So, such a prediction might not be a practical possibility. This in the case when you flip a coin. But in principle, any such area can be surmounted by any sufficient work and relativistic, mechanics is also deterministic. In contrast, quantum mechanics is probabilistic. That is, even in the presence of exact knowledge and current situation that is improbable, to predict its future exactly, regardless of how much work and care one invests in such prediction.
Okay, great. Now again, we have this thinking game.
Yes.
So we have a scientist here, not a philosopher. What is he telling us? Is he agreeing with Sider, disagreeing with Sider?
He's saying that the same thing.
Sorry?
He's saying quantum mechanics is deterministic.
Yeah, what did Sider say?
He said the same thing. Or
Yeah,
he said
this,
more-
this scientist is saying the exact same thing as Sider. Except Sider actually noted there's at least one interpretation of quantum mechanics according to which determinism may be true. He didn't really spell that out, but if you read really carefully, that's kind of what he's saying. But this guy doesn't even mention the existence of interpretations. He just comes right on page 2 of his book and just tells the reader, quantum mechanics is indeterministic. End of story, mic drop. Right? He's saying classical mechanics is older theory that we now know is not true. That theory, which by the way got replaced by special relativity, general relativity, quantum mechanics, statistical mechanics, our old physics said determinism is true, but our new physics says it's not. What do you think most people would come away thinking if they picked up this book and started reading, they got to page 2? If they read some scientists just tell them that determinism is false, what do you think they're going to come away thinking?
The guy's out of his mind.
Sorry?
The guy's out of his mind.
I can't, sorry, Ellie, I can't.
The guy's out of his mind.
Why would they think he's out of his mind?
Because, I mean, it's like in practice, not in practice, but like, you can pretty much ask anyone on the street and they would say determinism is true just because.
This is the amazing thing. People on the street will tell you all the time determinism is true. You know what most scientists say about that? They're wrong. They're wrong. This is again something that we have happen again and again in our society. And this is why if I were you, I would be really careful about the social media. We have lots of people in our society that believe lots of things that they say science teaches, when most scientists say it's false. It's really easy to find people who would tell you we don't have free will because determinism is true. 2 problems with that. Number 1, a lot of scientists tell us determinism is false. Number 2, we got a lot of philosophers that say even if determinism is true, it doesn't pose any threat to free will. Are you guys following me? Is it really that surprising to you that we would have so many scientists that say that determinism is false? By the way, this guy's a brilliant scientist. He just kind of told you determinism is false. This guy isn't stupid. You know, he's like a leading expert on quantum mechanics. Why would he say that determinism is false? Because he says, just look at the equations. They're not deterministic equations. And again, someone can say, well, they're written in the language of math. But again, here's a little, what are the odds, again, if we roll 2 dice, 2 6-sided dice, that they're going to come up both 6s? What are the odds?
136.
Well, is this math or not? Tell me, is that math or is that not math? 1 over 6 times 1 over 6 equals 1 over 36. That's math. Is this telling you if you roll 2 dice, you're definitely going to get 2 6s or you're definitely not? Doesn't matter if it's written in math. Math doesn't have to be deterministic. It could be probabilistic. And this guy's saying that's how the actual math of quantum mechanics works out. Is this what most scientists say? The ones I've talked to, yeah, I might have mentioned this. There was a guy, I think I did. There was a professor, again, Professor Allen, you remember him, Tom Carter. I remember him many years ago when I went down to his office right around it's actually just, it was right around that corner, actually. It's like, I think literally the next door over, basically. And I went to his office and sat down with him, and this guy's a physics professor, got his PhD from Duke in physics. And I said, what do you think about determinism? And he said, it's false. We've proven it's false. End of story, mic drop. We're done. And you could ask him, well, why would you say that? He'd say, look at the math. There it is. We're done. Mic drop. We're out. I've talked to a lot of physicists over the years about this, and they've basically all said the exact same thing that Tom Carter has said. We're done, we're done, we're done. Okay, what are you all expecting me to say next? Do you think I'm gonna, I feel really bad for doing this. Do you think I'm gonna agree with all this, with these scientists? I'm not. I'm absolutely not. Why not? Well, pick up this piece of paper. You got this one, right? This is by William Mullen, who was a physics professor at University of Massachusetts Amherst. And we won't look at page 31 yet. Let's skip over to page 44. The top left-hand corner, I've got in corner quotes. Now look, we're not going to go through all of this in class, but okay, we'll just do it this way we can. Furthermore, in a rather amazing theorem, John Bell proved rigorously that any realistic theory, that is one using hidden variables, we'll talk about what that means, that is also local, that means any experimental result depends only on local settings, does not depend on faster than light signaling from afar, which we've got evidence actually against that, leads to a mathematical condition that the data in a suitable experiment must satisfy. But quantum mechanics makes predictions that violate this condition, as real experiments agree with quantum prediction. Bell's theorem, which we'll treat in chapter 7, is perhaps one of the most remarkable proofs ever made in science or philosophy. It's actually kind of interesting, it says science or philosophy here. It allows one to experimentally disprove the possibility of a whole class of physical theories of nature, namely those that are local and realistic. As a result, physicists are often content with an interpretation of quantum mechanics that is non-local, so it has spin correlations or arbitrary distances. It says no hidden variables and or is non-deterministic, it's probabilistic. So at first glance, what is this guy telling us? There are different theories of quantum mechanics, and some actually do uphold determinism. Are you guys with me on that? Mullen is actually going into the different interpretations, and now he's going to start telling you how they disagree with one another. By the way, this whole thing about local just means that we don't have particles seeming to interact in a way that would violate the stricture that you can't have faster than light, that signals faster than the speed of light. Okay. When we talk about realistic and hidden variables, basically these hidden variable theories are ones that look at the standard equations of quantum mechanics, like the Schrödinger equation, and basically say there's some extra stuff going on in physics you're not aware of. These typically give us deterministic interpretations. Okay? So basically what he's doing is saying that some physicists prefer deterministic and others not deterministic theories. There are some folks that prefer deterministic, that do prefer deterministic theories. Mullen himself actually does not. He argues in his book that we should go with indeterministic theories. Okay? So you all tell me, how do we answer question number 5 on the assignment? Question number 5 asks, is quantum mechanics deterministic or indeterministic? What do scientists say about the issue? You tell me, what's the answer? I don't think we can quite say that.
I think we have one vote for indeterminate.
Can we say it teaches determinism? No. Can we say it teaches indeterminism? I don't quite think so. What should we say about this? Is quantum mechanics deterministic or indeterministic? We have no freaking clue. We don't know. We just don't know. Here's the way I'd write it up. We've got some math. We don't know what it means. We have different interpretations. We have some interpretations that uphold determinism, and we have some that give us indeterminism. And we don't know which interpretations are right. We're not even close to proving anything about this, and it's hotly debated among scientists. We don't know which interpretation is right. So is quantum mechanics deterministic or indeterministic? We don't know. If you ask the physics professor that one of our former physics professors, Tom Carter, he would say determinism's false. He said we've proven it. Double slit experiments prove determinism's false. I've heard so many physics professors say that. Determinism is false. Determinism is false. Determinism is false. Just look at the math, look at the math, look at the math, you're done. But other physicists say, not so fast. That math is not all the math that there is. We need to add some extra structure to the theory. This is the hidden variable interpretations. And when we add in those additional factors, actually determinism is restored, and we have determinism. And another scientist like, yeah, I don't believe that those hidden variables are really real. You don't have enough evidence for them. And they're like, nope, I got enough evidence for them, and they can't agree, so we don't really know. We don't know. A really interesting question would be what percentages of physicists side with which interpretations. Honestly, I can't really tell you that with confidence, but my sense from talking with folks over the years is probably most scientists favor indeterministic interpretations. I've just heard so many physicists tell me we've proven determinism is false. And I've never actually met a physicist in my life personally who actually went for a deterministic theory. And whenever I ask about them, I'm like, well, what about those interpretations? They're usually like, yeah, there's some people out there who think like that, but that's not really what most of us in the field think. But I don't know. I mean, that seems right. That seems to fit my experience, but I don't know for sure. What can we take away from this, y'all? I really want to drive this home. But can we put our phones away, please? Something like class? What can we take away from this? Again, we have people in our society all the time. It'd be really easy to find people on the internet telling us that we don't have free will because determinism is true. And if you ask them, why is determinism is true, they'll say, because that's what science teaches. Is that right? Is that what science teaches? You'll also find some people who say, no, that's wrong, because quantum mechanics says determinism is false. Is that exactly what science teaches? Y'all, I think we got to be really careful about relying on the internet for stuff. Here's another thing, too. This guy Steyer that you just read, this guy's an actual scientist. What did he tell you? He told you that determinism is false. I mean, I hate to do this in class, but is he right? Not exactly. What did the philosopher tell you? Determinism is false. What do a lot of physicists tell you? Determinism is false. What do some scientists say? Not so fast. What's another takeaway? What's something we should take away from this? What if we're sitting at home and we're really curious one day about whether we have free will? What lessons can we learn from this about how we could conduct an investigation? Mitzi, what do you got? Put it this way: can I trust the first thing I read on the internet? Can I trust the first thing I read on the internet? Can I trust the second or the third thing? Should I just trust the first expert I talk to? What if 2 or 3 experts give me the same answer? Can I even trust that? Not necessarily. Is there any question that we could ask to try to get more reliable results? So I go to one scientist and I ask, what is it? And he says, determinism's false. And I go to a second and I go to a third. What question can I ask to try to get a better sense of what the scientific community thinks?
Does anyone disagree?
Does anybody disagree with you? And who are they? And why? A lot of times people, they won't tell you that. They'll just kind of say, here's how it goes. And the stuff on Wikipedia is a gross oversimplification of a gross oversimplification of a gross oversimplification of what you're finding in these books. And again, here's another thing too. I think we fall into these kind of these traps of oversimplifying things all the time. We kind of expect science to have just proven already whether determinism is true or not. Actually, it hasn't done any such thing, and a lot of scientists say it will never, ever do such a thing. We'll get to that in a minute. I want to have a little I want to do a little side note for a bit on this. Oh, by the way, so for question number 4, yeah, what do philosophers and scientists, or what do scientists say about this? They disagree. Many favor indeterministic interpretations, but some favor deterministic interpretations. But if you go back to the quantity thing Professor Allen did the other day, I kind of implied just now that the indeterministic interpreters outnumber the deterministic interpreters. I'm not even sure that's quite true, but that seems to me to be true. The second half of the question, number 5, asks, what about classical physics? What did Steyer say about that? That it's fully deterministic? Actually, that's not true. There are counterexamples to determinism in classical physics. That's one right there. If you look at the equations for classical physics, if you have a perfectly smooth dome and you set like a marble on the top of it, the equations actually don't tell you at all what will happen next. There's actually a number of scenarios that are compatible with classical physics that the theory doesn't actually tell us what's going to happen. It's actually not clear that modern physics has given us one deterministic theory of physics yet. But there's debates about pretty much all these theories. What would I write down for 5? I'd say that classical physics is widely believed to be deterministic, but it's not fully deterministic. It's maybe close, but not quite. Maybe close, but not quite. All right, I'm going to do a little bit of this maybe will bleed into the religion unit. I want to just do a little sidebar to just help us to realize, I think, how often we're engaging in simplistic thinking, right? So I don't want that to sound too harsh. But I teach classes in Old Testament and New Testament here. I'm teaching Old Testament this term. I'm teaching New Testament next term. And people often ask me, they'll say, do you think we should read the Bible literally or non-literally? And we have a lot of debates about this in our society today, whether we should read the Bible literally or non-literally. I do not want to get into the Quran. I do not want to get into the Vedas. I do not want to get into the Purans. We're going to talk about the Bible. All right. You guys have probably heard debates on this, right? Whether we should interpret the Bible literally or non-literally. Okay. What should we think about that? You might say, I don't know, I've never read the Bible. Okay, let's see if we could do any critical thinking, though, to just kind of help us out with this. If someone asks you, should we read the Bible? What do you think with this idea? We should read the Bible literally or non-literally? You could be a Christian, you could be a Muslim, you could be a Buddhist, you could be an atheist. Do you have any idea what you might say? Or maybe you don't have to have a position, but at least are there some questions we can ask about this question that might help us to work it out? Does it seem like there's anything problematic about the question? We see any potential problems with this question? Can we see what questions we might have to answer before we could even answer this question? Yeah, Earl.
I think nowadays people make the Bible dependent to like their own views.
Okay.
Like sometimes like they can swap from like reading it literally to non-literally.
Okay.
Just to defend their own.
Okay, so we got to be careful when it comes to religion and maybe everything that people try to exploit things for their own ends. Yeah. By the way, I think people do often have this habit of reading stuff literally kind of when they want to and not reading it literally when they don't want to. And you really got to wonder, is anybody really trying to figure out what their texts say, or are we all just coming with our bias and then we just make the text say what we want it to say? I think that's a really legitimate concern we could have with all these traditions. Anything else? Maybe we'll see some examples of that. Does the question seem problematic in any way? Should we read the Bible literally or not literally?
It could be both.
Maybe it could be both. The question is often already skewing us to think that we should read it all one way or all another way. Maybe it could be read both at the same time. Maybe some passages should be read one way and others another. Maybe some should be read both. What other questions should we be asking before we try to sort this out?
What does it say?
Sorry?
What does it say about that?
What does the Bible itself say, right? Oh, great. What does the Bible say itself? Does the Bible, here's the way we could sharpen it. Does the Bible itself ever tell the reader that a certain passage in it should be interpreted literally or non-literally or both? It actually does, which is extraordinary. And I think probably one of the clearest examples of that is Galatians 4. So, just really quickly, if you're not familiar with the Bible, that's really all right. You could take my If you want, you could take the New Testament class in spring. But this letter to the Galatians was written by Paul. Paul wrote a lot of letters, some of which became whole books of the New Testament, right? You might think of that as like the Christian part of the Bible, and it's kind of loose, but there it is, right? And these books are super, super important part of the Bible for Christians. Super, 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 super important. What Paul is doing in a lot of these letters, this guy Paul, is he's kind of telling you, he's really getting into all these deep theological questions, including how do people get saved, how do they get to heaven, and that's actually what he's talking about right in the midst of Galatians, is how people get saved, how they get to heaven. And he's talking about this story from the Old Testament about Abraham and Hagar and Sarah and Ishmael and Isaac. Does anybody know who these people are, really quickly? Elian, do you want to, can I put you on the spot a little bit?
Yeah, Abraham's like he's the guy who put his son, or that guy who tested.
Yep, Genesis 22,
Yeah.
right? He was put to the test. He nearly sacrificed his son.
Hagar and Sarah. I don't know. Who are the other people?
Isaac.
Isaac. Yeah, Isaac.
Isaac.
No, not Isaac.
Okay, so just really quickly, like in the Old Testament, Abraham is this guy that God calls to kind of be the father of the nation of Israel, okay? And at this point, he's like 75 years old, and he doesn't have any kids, okay? And God says, you're going to have a lot of kids. His wife is also like as old as he is, maybe. She's definitely old. I don't think we get her exact age, but she's pretty old. And they're kind of like, are you really going to let us have kids? And at a certain point, years and years and years pass. And they kind of think, you know what? Maybe the problem is that Abraham's wife, Sarah, is not supposed to have the kid. Maybe Abraham's supposed to have this kid with another woman. And so Sarah actually, his wife, comes to him and says, you should sleep with my Egyptian servant. Okay? And Abraham's like, okay, I'll do that. Right? And so he sleeps with this woman, Hagar. Who, according to the Bible, is actually not his wife. And she has a son, Ishmael. And God basically says, this kid is not the kid that you were supposed to have. You will eventually have a son with Sarah. And eventually he does. And that is really how the nation of Israel comes about, according to the Bible. It's from Abraham and Sarah with their son Isaac, not Abraham and Hagar with their son Ishmael. Okay? There's some of this stuff is viewed actually significantly differently in Islam, and actually different Muslim scholars have viewed it in different ways. We're going to just stick with this version from the Bible. Now, if we go to the New Testament, what do we see Paul doing? He's talking about how to be saved, and he's actually bringing up this old story about Abraham and Sarah and Hagar and Ishmael and Isaac. You could just see right here, example of Hagar and Sarah. Right? And he's talking about Hagar and he's talking about Sarah. And what does he say right in verse 24? Now this may be interpreted allegorically. Actually, the Greek doesn't really say it may be interpreted allegorically. It basically says this is an allegory. The translator actually kind of changed this on this. In the Greek, Paul says this is an allegory. What do we normally think an allegory is? Professor Allen, do you want to talk about this? How do we normally think of an allegory? Is an allegory literal or non-literal?
It's supposed to be not literal,
Right.
but it's supposed to teach us a lesson of some sort, or impart some degree of wisdom. So interestingly, the Bible's full of allegories, especially the New Testament.
It's full. And what did Paul say right here? He said, go back to the Old Testament history, that story of Abraham and Sarah. That is an allegory. And what is the allegory? You should interpret these women as representing, as standing for two covenants, kind of different contracts that God made with people, or kind of two promises he made, two pledges he made. We could really get into this. I don't want to get too into this because this isn't a Bible class. But the point is Paul actually says he literally says, you should interpret this non-literally. Does he mean you should not also interpret it literally? Elian, any guess? Is he saying we should only interpret it literally, non-literally?
No.
I don't think so. I'm sure Paul thought this stuff all really happened. What is Paul telling us? It could be both. It could be literal and non-literal at the same time. Do you think that's something that in our society we appreciate, that something could be literal and non-literal at the same time? Put it this way, when people ask, should we interpret the Bible literally or not? Or I'll even put it this way, a lot of people say you have to interpret the Bible literally. If you don't, terrible things happen. What do you think they mean? What's the terrible thing that's going to happen?
Like, what she said, like skewing stuff.
That you might skew it, right? So if we want to avoid skewing it, we should always interpret it literally. But then the text tells us you should not just interpret literally. Can we find any passages where maybe we're not supposed to interpret literally at all?
Maybe the parables.
The parables. I'll go to Jesus' commands in the Gospel of Matthew, right? Lust. You have heard that it was said you shall not... This is Jesus talking, right? This is like his most famous sermon ever in the Bible. You have heard that it was said you shall not commit adultery, but I say to you that everyone who looks at a woman with lustful intent has already committed adultery with her in his heart. If your right eye causes you to sin, tear it out and throw it away. For it is better that you lose one of your members than that your whole body be thrown into hell. And if your right hand causes you to sin, cut it off and throw it away. For it is better you lose one of your members than your whole body go in hell. What did Jesus just say if we interpret him literally? If we interpret Jesus literally, what is he telling us? If you struggle with lust, what should you do? If we follow him literally, you should cut your eyes out. I don't really troll people, so I just say this now as kind of a joke. I don't really do it. But when people tell me I read the Bible only literally, I do kind of want to say, it's amazing you don't struggle with lust. And they might say, what are you talking about? Well, you haven't cut your eyes out. And then they'll say you're crazy. I'm like, well, Jesus said, cut your eyes out. I mean, I think if you read between the lines of it, he's also saying if you're a guy, not to be, maybe you should cut your penis off. Not too many people are going to go do that. Cut your hand off, I'll leave that to your imagination, how that might apply to people. How many Christians actually who say that we should interpret the Bible only literally, how many of them cut their eyes out? Hopefully none. Does that mean that they think they don't struggle with lust at all? No. They're not interpreting it literally. Do you see what I mean? Can anyone by the way, does the Bible itself tell us? Did Jesus say, psst, don't take this one literally? Is that what he said? Then how do we know? How do we know whether we're supposed to take this stuff literally or not?
It's open to interpretation.
I think you kind of have to use your own sense.
Yeah, it also says in Leviticus,
Right.
don't cut yourself.
It also says that you know what I mean, back in Leviticus. Right? So, yeah, there's actually different interpretations of that too. What does that even mean, right? We have to rely on our own brains. Why is that so scary? Because what did it really tell us? We could actually engage in self-deception. Is there any foolproof way is there any means we can use to guarantee we will not engage in self-deception in my building? There is not. Does this mean we're never supposed to interpret anything literally? What do you think maybe we should interpret? Is there anything that seems like Jesus is saying here we should take seriously? Sometimes people say, I don't interpret the Bible literally, I interpret it seriously. I don't like that either. Because I think there's plenty of stuff we're supposed to interpret literally. You know what I mean? But this text is telling us Jesus was a real person. I think we're meant to interpret that literally. You know? Can you see is there anything that Jesus might mean seriously? Maybe not quite literally, or maybe there is something literally. Is there anything he means literally here?
27.
Don't commit adultery. I think he means that literally. This is the thing I just find so interesting about this. I hear a lot of people tell me you have to interpret all literally or these terrible things will happen. They will not follow it literally, not all of it. And then people see that problem, and what do? They say, don't interpret literally, interpret seriously, which means never interpret literally. Does it seem like any of these are good ways to approach a text like this?
No, because it's super extreme. Extreme's always bad.
Y'all, I think we've got an issue in our society. We are constantly oversimplifying things and falling into these kinds of extremes. And maybe sometimes all we need, I mean, if college should sing well, I don't think it would actually take a great deal of critical thinking for us to be able to work some of this stuff out. I think it might take us 5 minutes, but I think that might be worth it. I think it might be worth it. There might be all kinds of stuff this text really is telling us you should take literally. And you might or you might not. And then there's going to be other stuff it's telling us we should take figuratively. And you might or you might not. And then some stuff may be both. And what does literal even mean? And what does non-literal even mean? And is there only one way of being literal and only one way of being non-literal? And we can start talking about metaphors in our language, and can we even really get away from them? And are they literal? But if I say, I like to use this example, if I say it's raining cats and dogs outside, am I speaking literally or not? Dog. There aren't actual cats and dogs falling from the sky, right? Does that mean that what I said is completely untrue? It could be raining pretty heavily. What does it even mean to be real in this context? Do you know what I mean? I don't know. Free will. We don't have free will because we're determined. Are we? No. Quantum mechanics, we're not determined. Really? Maybe these are all kind of oversimplifications. By the way, y'all, I don't think science is going to solve this problem for you at the end of the day. I don't think it is. I think we should consult it, but I think we're going to have to dig a little deeper. Okay? All right, now to set up the next thing, question number 6, and I only got 5 minutes, so you're just going to have to remember this for next time. I'm going to set some up for next time. No, because we got to do a
We
thing.
got one more little task to do. Oh, shoot, one more.
We're going to just... Oh, wait, I need to add something. This is actually educational. Do you know the Wampa? This guy?
Star Wars? No.
Okay. Empire Strikes Back. Greatest film ever made objectively, no arguments. Objectively truth, I just spoke.
What is that? Harry?
Begins on, it's the Wampa, begins on planet Hoth. And Luke Skywalker, whom you all know,
I don't know.
you're going to watch these over the break. He's captured by this Wampa and hung up from the ceiling in his cave. He kind of ices his boots into the ceiling. And just watch this magnificent scene. It was different when I was a kid because Lucas, he kind of added some special effects, which was objectively wrong to do, and made it difficult to find the originals. So it looked a little different when I was a kid watching this on VHS.
What was it when you were a kid?
I think it looked even better. I don't like the new effects. All right, but here it goes.
What was it?
It was kind of the same, but the monster looked a little different.
When did you wear the little space outfit?
Ellie, do you want to hit the lights? Maestro, thank you.
How much does it like you wearing a space outfit?
He's stuck, but watch this. It's so cool. You're going to become a Star Wars fan right now, Mia. Like 90% chance. It's so dope. Then he runs out of the cave in a snowstorm, and
Ew.
nice one is that when he slices it off, he cauterizes it so it doesn't.
Okay. Elian, can you hit the lights?
I'm so not interested.
Okay,
I
how did
you
he?
have a figure of this at home where the arm comes off? Just for realistic work.
How did he get the lightsaber to come into his hand?
He used the,
Fourth.
there we go.
Does the Force look like science or magic?
A little bit of both.
Why is the Earth going around the sun? Why is Earth going around the sun?
As you get older. Birthdays.
What's keeping the Earth going around the sun and the
Oh,
other
gravity.
planets? Gravity. How far away is the sun? Like 93 million miles? It's pulling the Earth from 93 million miles away. He pulls the lightsaber from a couple feet away.
He's got gravity.
This kind of looks like magic, except is gravity magic? What even is gravity? This is what we're going to start on Monday. Is we're going to talk about how when Newton came up with his equations of gravity that say that between any two massive objects in the universe exert a gravitational attraction on one another proportional to their masses and inversely proportional to the square of the distance between them. Actually, a lot of people said, Newton, that looks like magic. And then the debate was, what do the equations even mean? And how do we interpret them? And we had like 19 different interpretations of those equations, which is exactly the situation we have with quantum. That's what we're going to do on Monday, is wrap that up and then talk more about Star Wars. Yes,
I was
Professor?
gonna say, and then Einstein came along and blew it all out of the water too.
And blew that all to bits, and we'll talk a little bit about Einstein's theory of gravity, general relativity, which is pretty wild. But what this will all do is help cement the idea that just because we have some equations, it doesn't necessarily mean that we know what they're even about.